What are structures? A structure is a collection of one or more variables, possibly of different types, grouped together under a single name for convenient handling. Structures are called records in some languages, notably Pascal, and when I was a young student, I used to program in Pascal. Structures help to organize complicated data, particularly in large programs, because they permit a group of related variables to be treated as a unit instead of as separate entities. Now, this quote comes straight out of the book C Programming Language, 2nd edition, by Brian W. Kernighan and Dennis M. Ritchie in Chapter 6, Structures. So now let's take a look at the purpose of structures and why you'd want to use them in your programs. So primarily, data organization. Structures help you organize related data items, simplifying access and management. Encapsulation. You can group different types in a structure, for example, integers, floats, and arrays, under a single name. Improved clarity. With structures allow you to represent complex data types and assign them meaningful names. Memory management. Grouping related variables reduces overhead of passing multiple arguments to functions. Modularity. User-defined types can be used in different parts of a program, and by doing so, you increase the reuse within your code. And finally, facilitate operations. Functions that operate on structures yield cleaner, more efficient code. Now, let's take a look at structures in action. Okay. I'm using Mac OS and iTerm. You can do this on Windows as well. And for my C Bootcamp folks, we've already got our computers all set up. If you want to follow along and you don't have your computer set up for C programming, you can go back and check out the earlier videos. I'm going to change. I'm in my home directory. I am going to change into my dev directory, so cd dev, and do a listing there. Change into my C Bootcamp folder and do a dir and take a look. Okay, so I'm just going to create mkdir structures. I'm going to create a structures folder and change into the structures folder. And then I'm going to open Visual Studio Code. Now, first thing I'm going to do is I'm just going to create a main source file, main.c, and get rid of this welcome screen. Close that down, and the text should be big enough so you guys can see. I'm going to start off by fleshing out the main. I'm going to start off with a comment up here that just says demonstrate structure or C structures. structures, and then struct for short, structs. Okay. Now let me see. I'm going to include the usual thing. So include standard IO .h and include string. I'm going to use the string copy. So I'm going to need the string header files, string.h headers. And then the main. And just get that return 0. Okay. And let me just compile this just to make sure everything's fine so far. Save it. Go to my directory, or go to the console, clear the screen, and type gcc main.c, and then the results on Mac OS should be a.out. Okay, so to run it, /a.out, and of course you won't see anything, but there's no errors there, and that's what I wanted to get to. On Windows, right, if you just do gcc main.c, then the output will be a.exe. okay? And then you can just run it the same way, /a.exe. If you're using the Git for Windows and the Git Bash, which is what I recommend, okay? Again, all that's covered in the earlier videos. First thing I want to do is I want to create a structure for a person. Now, this will be a multi-part video in that I'm going to start off with some array of strings for first name, middle name, last name, right? You usually see a lot of that. And then I'm going to go into how to store a person's birthday and calculate their age using some time functions. Okay, so that'll be in another video, but that's why I'm going to start off with this particular organization. So define. The first thing I want to do is define a constant called max string length. Okay, and I'm just going to set that to 25. Now, next thing I'm going to do is I'm going to define my structure. Okay, so I'm going to put a comment here. Define person structure. All right, and actually, I think I'll make that lowercase p and put a space after that. Okay. So the way that you define a structure is struct. That's the keyword, and then you give it a name. So in this case, person. And then open bracket, right? Open brace, close brace. And then I go straight down here to the close brace so you don't forget it and put a semicolon there. And then back in the body of the person structure, I'm going to say char. I'm going to create an array to store first name, middle name, and last name. So char, first name. And I'm just going to use max, right? Max string length. You can speed up this part. I might speed up this part of the video because it's just a bunch of repetition. Char, middle name. But, you know, I'll go slow here because then you can keep up with me when you're typing. Max string length. Okay. And then semicolon. And char, last name. Max string length. Just like that. Okay, now we have our character, or we have our structure. Very simple at this point. It just has 3 arrays for first name, middle name, last name. Now, I'm going to create then a type definition. There's a couple ways to do this, right? But this is my preferred way. So we've got this structure called person, and I used lowercase in this case for the structure name. But now I want to, now instead of, I'd like to refer to the struct person as a type that, you know, a type name without having to reference struct person every time. So you do that with the type def. So type def, right? Okay. And then struct person, and I'm going to call it capital P, like that. And then semicolon. So now I have a new type called person, which is a structure, right, of type person. That's what it represents. It's kind of like an alias, right, to that type. Now that we have, okay, a structure called person, we can create objects with this person structure. So I'm going to come down in my main, and I'm just going to create, I'm going to say person P1, okay, just like that. So I've created me a variable called P1, and now I can set the first name, middle name, and last name. Now the way that we do that in C is with string copy, strcpy, string copy, okay, and then open parentheses, right? Okay, and so P1 dot first name, okay, that's the destination array, and then I'm just going to say Rick, like that. And then I'm just going to copy this, right? So I'm just going to grab that and copy it 3 times. And I'm going to change this. So this will be middle name. Oops, sorry. Middle name. And last name. Oops. Fumble fingers. W. Millar. Okay, now that we have, we've set. So at this point, we've copied these string constants into the fields, right, or the properties. So how am I accessing these elements, right, of the structure? First off, I've got a structure. I also created a type def called person, right? So this essentially is just another name for a a person structure. In my main function, I've created an instance or a variable of type P1, right? And then I use the string copy function, and the string copy comes from the string.h library or string library. And then you give it a destination. So P1, now P1 dot, you use the dot operator to access properties. You could say these are fields or properties of a person structure, okay? You can also use the term object, right? We're not using C++, right? So that's probably not a terminology that a C programmer would use, but it's an object is just a location in memory. When we create a type or a variable of type person, then we've reserved the spot in memory, right? So it's an object. And then string copy is a function. We give it a destination by accessing one of the properties, which is going to be has to be an array that can take the string that you're going to pass to it using the dot operator. Okay, so P1 dot first name, P1 dot middle name, P1 dot last name. Now to check this, okay, we can print. All right, so now I'm just going to printf. All right, and I'll say, I'll start off here with first name, and then a colon, and then a percent s, and then a /n, okay, and then a comma, and then P1 dot first name, like that, and then carriage return right there. And don't forget your semicolon for you Python people. Printf. Probably if you're a Python programmer and you're coming to C for the first time, it's those semicolons that'll kick your butt, right? So middle name. All right, and then %s /n, comma, and then P1 dot middle name. There it is. We got the autocomplete. And finally, printf last name, colon, %s /n, and then P1 dot last name. Now I'm going to run this semicolon, make sure everything's good to go, so I don't see any red lines underneath my code. That don't mean it won't have a problem with it, but we'll see. Save everything one last time. Remember, if you got a white little circle up here that you haven't saved your file, and then return to your console, clear the screen, compile, and then run it. All right, so here we got first name, Rick, middle name, W, last name, Miller. Now, let's create an array of these structures and a function which can then iterate over the array and print out each of the values for the person in each array. Okay, let's return to the code. And I'm going to go up here. So I've got the structure, obviously, quick review, right? And the type def. So the type that we're using is person. Okay, so now let's create an array. Let's declare an array. So I will declare the array right underneath of P1. So I'll just, we'll do person. And I'll call it people array. And I'll give it 5 elements to start off with. Now, come underneath of here. In order to deal with arrays, right, you need to know a couple things. One, you need to figure out how many elements there are. In this particular case, there's 5, right? So when you create an array like this, you'll know how many elements there are, but you could dynamically allocate an array too, right? And I'll have a separate video on how to do that. But essentially, it's nice to know if you use the sizeof function. There's a function called sizeof that will allow you to calculate pretty much dynamically, like how big the array is and how many elements the array contains. Okay, so for example, the total amount of bytes in an array is calculated by the size of the type, right? And the number of elements that are in that array. So let's start off by figuring out how big a person object is. Now it should be 75. Okay, so we've got a max string length of 25, and then we've declared the structure to be 3 properties or string arrays, right? Or arrays of chars, I should say, 3 strings with length 25. Okay, so it should be 75. So let's just see if that's the case, right? So I'm going to declare an integer here, right? And I'll say total bytes. And then I'll use the sizeof operator. And I'll just feed in the name of the people array. Like that. And then I'll print that out just to see how many there are there. Okay. Now this will be the entire array. Okay. So this will be people array, however many bytes are in there, right? So 5 times 75, 300 and something. So hang on, let's see what we got. So printf. So this would be the total size of the array in bytes. And then %d. And then /n. And then just feed in total bytes. Like that. Okay, now semicolon. Okay, now we can run this and just see what that total is. So let's go ahead and compile this. So gcc main.py or main.c. Python, I got Python in the brain. /a out. All right, so the total size of the array in bytes is 375. So now let's calculate the size of a person structure, okay? Because we're going to need these calculations to figure out how many elements are in the array without like saying, oh, I've got 5, right? Like, embedding that value, even though it's, we've already used it to create the array. So let's come down here and we'll say int person struct size. And then we'll use the sizeof. Sizeof. And then just person. So you can just use that type name. Okay. And then again, printf. I'm going to print the size of that person. So printf. in bytes, colon, %d, then /n, okay, and then comma, person struct size, semicolon. Now let's go ahead and run this, and we'll get that value. CLS, main, GCC main, and then A out. All right, so our person structure is 75. Now, it depends on how many, what types of data that you have in your structure. You may, because sometimes depending on, like if you have shorts in there or ints, right, and you've got a 64-bit architecture, your structure may be actually bigger byte-wise than each individual data type that you have in the structure. And that's because, you know, it depends on if your compiler is packing those, you know, like the bytes are, the data types are sharing a word, right? Or they've been packed together. Sometimes they get packed together, you know, to save space. So, okay, so now the next step is we are going to, what I want to demonstrate here is that although we've calculated these, right, like total bytes and person struct size using size of people array, right, we can combine those, which is probably obvious, right? And the next one I'm going to get is the number of elements, right? So int, okay, people array elements. So the first I'm going to do is I'm going to use these values, right? Int or total bytes. So this is essentially the formula. So total bytes divided by the number of bytes in the structure, right? So person struct, right, size. Now that's going to give us the number of elements in that people array, right? So let's go ahead and print that. Printf. Oops, don't forget the quotes. Element count in people array. Okay, colon, %d, %d, backslash. Oops, okay. And then comma, and people /n. People array elements. Okay. Let's save this and run this. Okay, so there we go. We have our element count. Okay, so that, like I say, the general formula is to figure out how many elements are in an array of structures. It's the total size of the array in bytes divided by the number of bytes that the structure is comprised of. Okay, and then one last thing, right, is we can just print out the you know, we can just combine those two calculations, right, instead of figuring them out individually. All right, so I'm going to just reassign it here. So people array elements equals size of, okay, and this will be people array, like that, divided by size of, okay, and then person. Oops, capital P, like that, semicolon. Now, I like to put a parentheses around these, right? Just to make sure. Okay. Just to force that association. And then print this again. I'm just going to print this one more time. And compile and run this, right? So, right, look, the reason I do this, right, is one, I show you how to calculate each of these values individually, and then we can just use this combined, expression to perform that calculation. So saved and run it. GCC, and then clear the screen, and then A out. All right, so obviously we get the same value. Okay, now it's time to create a function that will step through. Well, actually, how do we set, right? How do we set the values of structures? Now, obviously, we're in an array, okay? So let's create a for loop. Okay, I'm just going to show you how to do, like, if let's say that you wanted to initialize. So these elements are not initialized at this point, right? So I'm going to initialize each of the elements, the person objects in each of the elements with a default value. Okay, so for i, so for int I, I'm just going to use a for loop equals 0. Now this is important. Int I, and see these array value, these values, right? Any variable that you have is not initialized to a good state, right? So make sure you initialize it, right? So int I equals 0, and then I, right? Less than people array elements, okay? Because we've made that calculation right here. And then semicolon, I++. Now what we're going to do is we're going to step through the array, and we're going to call string copy and just give it a default value. So I'm going to say strcpy, right? And then it's the source and destination, or destination, and then what you want to initialize it to. And you saw that in the previous segment. Okay, so people array. And then use the indexer to access that element. And then you can just use the dot operator, first name, okay, comma, and I'm going to set it to, John Doe, right? John, okay. And then I'm just going to copy this line and bring down here 2 more lines. And then this will be middle name. Oops. Okay. And I'll just say J. And last name, Doe. Okay. Now, in order to print this out, we could test 1 or 2 of them, and then I'll do a function that actually goes through and prints all the data, okay, for the entire array. So I'm going to save this, and I'm going to come right down here, and I'm just going to, let's just print out 1 of them, right, to see what it has. So printf, and I'll say first name, like this, %s, %s, okay, and then comma, and people array, and I'll do the first element, 0 dot first name, okay, and I'll go ahead and just copy that. I just want to test that I've, that the initialization is working, at least for the first element. And then middle name, and then last name, and then come over here. So this will be middle name, last name. All right, now let's compile and run this, and let's make sure that this initialization for loop is working correctly, and then I'll get into the function that actually prints all the data. All right, so control save, and there's an issue too that you need to be aware of. All right, so my turn. All right, so clear the screen and compile and run it. And we get our name. It's not very pretty, right? So that's because I didn't put any carriage return. So let's go back and fix that real fast, right? So it doesn't look so horrible. So /n, right? /n and /n. All right, so control save. Let's go back and run it and compile it. CLS, GCC main, A out. That's better. Okay, so we've initialized our array. I showed you how to calculate the total size of the array, and then figure out how many elements or the size of the structure, individual structure, and then using those two values to calculate the number of elements in the array. So let's create a function that goes in or that you can use to print the number of all the data in the array of structures. Okay, so here's the main, right? We're in the code. Here's the main function. So let's come down below the main. Actually, we need to create a function prototype. Now, I'm going to do this the way that you would probably set out doing it until you realize that you'd have to provide the size of the array to the function. And I'll show you why it can't figure that stuff out for you. All right, so this function is going to take in an array, a pointer to an array, and print out the data that the array contains. It's going to be like a for loop, right? So this is the method signature. It doesn't return a value, so it's a void. And the name of the function is print people array, like this. And it takes in a person and a pointer to an array, like that. Okay, now we're going to come down. I'll make another space there to underneath of the main, and we're going to implement this. So void print people array, right? And then person and star array. Okay. So again, we're going to use a for loop. So for int I equals 0. Okay. And then I less than, I'll put a space there, less than, and let's just try using the calculation, this right here, right? So let's say we wanted to do this. Like that. Paste that in, semicolon, and then I plus plus. And open brace, closing brace. Okay. So now it doesn't know what people array is, right? So we're going to have to change this piece right here. So it has array, like that. Okay. And then for the body of the for, we're going to say printf, and then person, and then %d. Okay. This is for I. So as I goes through, will print the value of I, and I think I'll put a colon there and then a space, and then %string %s / tab, okay, space %s / t, right, for a tab, space %s and then /t, okay, and then actually no tab after that third one, right? That'll be first name, middle name, last name. We'll do a /n, okay, and then comma, and then we'll do I will be the first argument, and then array I first name, array I dot middle name, comma, array I last name, like that, and then semicolon. Now we can just go ahead and I'll take this and just do a return here and a couple spaces over, just like that, to continue that on the next line. And that's it. Let's see. Control save. Now let's now in order to run this, or to actually print the array, we're going to have to call this function. So print people array, and then pass in people array, like that. Okay, and save that code and run it. So CLS, and then gcc main.c. Okay, so we get an error here because it says, warning, size of array will return the size of the pointer, not the array itself. All right, so if we go back to the code and we just hover over here, we can see that it's telling us that the value of the array is unsigned long, 8 bytes, okay? The size of the person is 75 unsigned long. So that's what we expect, right? 75 bytes for the person. But this is this should be 375, right? So if we put a star here, like it's telling us to do, that's really just giving us the first element of that array. All right, so now when we hover over, it says 75 UL. So that's not giving us, that's only giving us 1, right? So if we just ran this, we'd only get, we'd go for I equals 0, I less than 1. So what would happen is it would never print anything. So let's go ahead and just see that happen, right? So, you know, so we're sitting here like trying to run your code, and so clear the screen, GCC main. So the error goes away, right? So it's happy. But then when we run it, right, we're not very happy. Well, it did seem to print 1, right? It printed the first one, right? It printed the first record. Okay, so person 0, John J. Doe. Okay, but we want to print all the records in there, okay? So here's what you do, right? So for this void print, at some point, you know, the compiler knows what the size of the array is, and that is in the context or the scope in which it was declared, right? So, and there's other ways to come around this. You could put a magic value and just say my array is X number long, right? Or so you'd have a variable that just kept the value of the length of the array. Okay, so I'm just going to say int size in my method prototype, or my function prototype. And then I'm going to come down here to the function definition and say int size, and then just replace this. All right, I can get rid of that with just size, semicolon. Okay, Now, when I call the function, I'm going to have to supply the size. So here, because I'm in the scope of this main, and the main knows, oh, I've declared this people array with 5 elements, okay? Then I can just use the calculation here, right, to calculate the size, right? I could also just use the variable, or just like I did in this particular for statement, right? But I'm just going to pass this in a set of parentheses, okay? And I've already got it in a set, so I can take one set out. There we go. Okay. There's the end. Okay, now save this. Now if we run this, we will get the proper output. Okay, so go back to the terminal, clear the screen, compile it, and run it. Okay, so now we get all of our John J. Does. Okay, so that's how you step through. Now, one other thing that I want to show you is the importance of initializing your variables. Okay, so I'm talking specifically about this count variable, right? So I'm initializing it to 0. Well, what happened? What would happen? Just so you would know what would happen if you didn't initialize this before using it. So I'm going to take that away. Okay, so for int I with no initialization, so God knows what value that thing would contain, right? I less than people array elements I plus plus. Okay, so let's go ahead and run this. So that's just the initial. We're not going to see anything for that initialization anyway, but it may affect the output. So let's run it. So clear the screen, and I'll go change the print people array function too. So compile, and then run it. Okay, so this is the effect, right? So there's no need to change the other one, right? Because this one shows it perfectly. There's no idea where this stuff got created, right? Because this I was not initialized, right? So you always want to make sure that you're initializing your variables. And this goes with any type of variable that you're using, any type of value that you're using in C. You want to make sure that you initialize it. Obviously, the same would hold true down here, right? If I were to change this, even though I may be initializing all the values in the array to a known state, if I forget to initialize this count variable, okay, and then I compile it and run it, let's see what that effect is. All right, so CLS, GCC main, right? So segmentation fault, right? So that would leave you scratching your head. Segmentation fault 11, right? So just make sure that you're initializing to 0, right? Or whatever value you want. And so that's it for this video. I just wanted to, just a quick review. The purpose of a structure is to gather up related data into a convenient unit so that you don't have to deal with separate variables to represent those values. So in this particular first round of this, I declared a person structure, right? Lowercase p. And then underneath of it, I used the typedef keyword. I repeated the struct person, which refers to this structure up here. And I created a new type that I'm going to use, right, in my program. Then I created a function function declaration, right? Prototype, a function prototype. I'm just going to put a comment here. I'll put a comment for each of these, right, as I'm going through them. So here we have type def, create new type. With type def. Okay. So create new type with type def, and then declare function prototype. Now you need the function prototype because in C, you know, before the compiler runs, right, we're using, and you make sure that, you know, you have to declare this prototype before you access it in the main, right? So we're actually calling this print people array here, okay? But the definition for it doesn't come till later. So the compiler, when it's compiling and linking, right, it says, okay, there's a name here. I don't know what the definition is, but it's coming. So just, you know, hang tight. So you provide the function prototype, right? And then here I've only declared one instance, and here I've declared an array of 5, okay? Now, I could declare array of 10, right? Let me go up here and do one more thing, right? Let's say that I wanted to say, I had a definition here, define. I'm going to put a symbolic constant. I'm going to say array length, like that, equals 25, okay? Or 10. I'll just do 10. 25 would be too gainly. Now I have array length, right? So then down here I'm going to replace this magic value. It's called a magic value, right? Because you're using a literal. And I'll just say array length. Like that. Okay. What's the error? Oh, expands to 10. That should be fine. So, oh, max array length. That's fine. Okay. There's probably something in the C that says, oh, you can't do that with that. But let's try running it, right? See what happens. So control save. You know what? Here's the problem, right? Equals. I'm a chucklehead. Let's get rid of that equal sign. And so we got define array length 10. And then that red goes away. Goes away, excuse me. Now, I could easily change like the length of my array when I want to. So this thing should work just fine, right? Because it calculates the number of elements dynamically. All right. So let's go ahead and save this code and run it one more time, and that will be it for this video. All right. So CLS and GCC main, and clear the screen one more time. We're having a few more outputs, and run it A out. There we go. So now we've got 10. Okay. So like I said, that's how to create a structure, how to access the elements of a structure by using dot notation. Okay. So like P1 first name, P1 middle name, P1 last name. There's your P1. And then for an array, you just declare an array of structures, and then you use the array offset and then the dot notation to get to each element or each property of the structure. Okay, that's it for this video. I hope you enjoyed it.